Okay. Hi, everybody. Good morning. So, today is Monday, March 4th, and you have homework 5 about 8.3 and 8.4 due. Okay, so we are still behind schedule. We're still in 9.1. Okay, but yeah, we'll catch up later. Okay, so let's see. So yeah, please work on your homework. And I realize that many of you didn't get perfect scores on your previous homework. I hope to see you more often in my office. So you know homework. I post the solution, right? And then your problem and the solution. Maybe it just changed some numbers, but the type of problems are similar. But if you have difficulty working on some of the problems, please come to see me. And yes, I'm happy to guide you step by step in my office hours. Or if you cannot come to my office hours, feel free to email me and make an appointment with me. Okay? Yes. So let's see. Last time we talked about how to sketch the graph, right? And we are in the three-dimensional space. And last time we did A and B. So what we usually do is um, look at the function, and x squared plus y squared equals a number. It corresponds to a circle. That's why what we did is we think about, okay, what is the smallest number it could be? It could be like the smallest is 0. So that's why we plug in c is 0 and we get a single point, the origin. And then we increase the z values and we try to plug integer points. That's why we pick z is 1, and then we get a unit circle. By the way, z equals to 1 is a plane, right? Horizontal plane. And then we increase the c values, and we said we want to get integer points. That's why we don't plug in 2, we plug in 4. Because if you plug in 4, it corresponds to the circle with radius 2, right? So the plane z equals to 4, we get the circle with radius 2. And then you get a paraboloid. And if you see like x squared, if you set the y equal to 0, do you get a z equals x squared? It's actually a parabola. And you know y equal to 0, it corresponds to the xz plane. Yeah, the xz plane. So I just want to talk about more. So if y equals to 0, that corresponds to the xz plane, and they intersect the curve, you get a parabola. You see here, you get a parabola. And what if now I don't let y equals 0? What if I let the x equal to 0? X equal to 0, it corresponds to the YZ plane. Then you intersect the curve, you get another parabola. So that's why this guy is called paraboloid. And how about the other picture? Okay, so let me look at part B. So what happened to the square root? Well, if we have the square root, we can square both sides because z squared is x squared plus y squared. And if we pick like z to be different number, if we pick z as 0, we also get the origin. If we pick z as 1, we also get a unit circle. But here, when we pick z as 2, we already get the circle with radius 2. So you end up getting a cone instead of a paraboloid. Okay, everybody? And furthermore, if you let x equal to 0, then you get on the yz plane, you actually get like z equals plus or minus square root of y squared. It's going to be plus or minus y. So you actually get you intersect the y-z plane. Do you see those two lines? Mm-hmm. Yes. Okay. So this is how we draw a surface, the graph of surface. Okay, part C. And so this means z equals square root of 4 minus x squared minus y squared. So if you see square root of a constant minus x squared minus y squared, the trick is square both sides. And move the x and y to the left, you get x squared plus y squared plus z squared is 4. This is actually a sphere. So standard equation for sphere is x minus a squared plus y minus b squared plus z minus c squared equals r squared. So this is a sphere centered at the point ABC with the radius is r. So this is equation of sphere. And now you see the center is at the origin. What is the radius? What square is 4? 2, exactly. So the radius is 2. So we draw the 3 rays, x, y, z, and it's a sphere with radius 2. Okay, so how do you draw it? I first draw a circle. Imagine that this is the circle on the xy plane, and then I draw another circle. Then imagine the sphere intersect the z-axis at 2. Okay, so this is a sphere. But here, look at our function. Our function is the positive square root. Okay, the positive square root, it corresponds to the upper sphere. So not the entire sphere, but just the upper one. Is that okay, everybody? If I put a negative square root, then it would be the bottom half, right? Okay. So this is part C. Now, how about part D? Okay, part D. Do you see there is no Z? There's no Z, sorry. My bad. Z is the function. So Z is here. Z is 3x minus 2y. Okay. I'm saying if you get 3x minus 2y equal to 0, then there is no Z. But here, there's Z. Z is f of xy. 3x minus 2y. Okay, everybody? So this is a linear equation. We know linear equation in R3 corresponds to a plane. Right? And let me see. Okay, how many points can fix the plane? 3 points. Yes. So we find 3 points. Okay. So draw the 3 rays. Okay. X, Y, Z. We need to plot 3 points. Okay. Let's see. Let's do the easiest one. If we plug in x is 0 and y is 0, what do we get? The z is also 0. It actually passed through the origin. Yes? Okay, let's do the next one. If I plug in x is 0, x is 1, and y is 0, what is z? what is Z? We plug in X is 1 and Y is 0. What's Z? 3. Yes, it's 3. How about we plug in X is 0 and Y is 1? -2, right? Everybody? Yeah, pick any 3 points. So 0, 0, 0, 1, 0, 3, right? So Y is 0, and then we go up 3 units. So 1, 2, 3, right here. Is that okay, everybody? The X is 1 unit, the Y is 0, so don't move in the Y direction. The Z is 3, we go up 3. Okay? And then this point is 0, 1, and then what? We go down. 1, 2, -2 here. You know what? My 3 point is not so good. So the plane looks like that. Is that okay, everybody? So maybe it's better to draw it in the GeoGebra, because this rotation, this position is hard to see. Let's draw it here. Okay. Okay. What is Z? 3x minus 2y. Oh, okay. So now can you see the plane? It's like that. So our picture is not so good, but if you rotate the x and y axis, you can see the plane better. Okay? Yeah. And yeah, here the plane is like that. All right, so this is how we draw the surface. By the way, in the exam, I won't ask you to draw the surface. Okay, you do calculus on the surface. Okay. But before we do the calculus, we want to understand what the surface looks like. Okay, next concept, level curves. So definition, we let f of xy be a function and let c be a constant. The set of all the point xy for which f of xy equal to c is called a level curve. We call c is the corresponding level. A collection of level sets drawn together in the same picture is called a contour curve or contour map. If you have ever gone hiking, you probably know what a contour plot is. So look at this map. You see, this is the river, right? And you get a lot of curves. They are actually level curves. So 4,800, it means along this curve, they're actually the same heights. Yeah, is it 4,800 feet or meters? I don't know. but you can imagine, if you go this way, your height is gonna be increased. But if you go this direction, your height is gonna be increased. Right? You get higher up here. Right? Everybody? Yeah, so example where we let x be longitude and let y be latitude, and f of xy represent altitude, elevations, and the coordinate xy. Then the counterplot for the elevation function is simply a contour map, like the type we use to hike. Look at the map. And the curves in this picture represent the path you can take to stay at a fixed elevation. Okay. Yeah. Okay, so, and this is another example. So suppose we have a table of elevation data. We can then draw graphs by putting the height at every point, connecting the dots with smooth curves, which results in something like the graph show. So we saw the tables before, yeah, in example 1, and then every different xy coordinate, you get a different height function, so you can draw the surface, right? And then z equals a number is a horizontal plane. You can use different z to cut it, right? Then you get different heights. You see, you get a lot of different curves, and then you switch down. And if you look at it from the top, and this is what you can see. You see the level curves. All right. So level curves, you plug in different z values, and you draw the curve, and then you can label. Oh, this is corresponds to what z value, and that corresponds to what z values. So this is how we get the level curves. Okay. Now the next example, draw level curves. So in the practice exam, you see I ask you problems about how to draw level curves. So drawing a surface is hard, but drawing a level curve is not that bad, right? Okay, so how do we do it? And in here, you have z equals x squared plus y squared. We try to plug in different values of z, okay? So let's see what the smallest z could be. So pick different values for z. So, and what is the smallest z? It could be 0, right? Everybody? The smallest z could be 0. Can z be negative? Look at your right hand side, x squared plus y squared. It must be greater or equal to 0, right? So the smallest z is 0. And if z is 0, you get what? A single point, right? Yeah, 0, 0. So let me use, okay, and when z is 0, we're at 0, 0. So this corresponds to z is 0. Okay, and now how about when z is 1? Okay, when z is 1, we get x squared plus y squared equals 1. Oh, what's this? See, it's a unit circle. Yeah, everybody, we get a unit circle. So we want to pick different values for z. But we want to pick good number. Okay, so we pick 1. Oh, we get a unit circle. Can we pick 2? No, we pick 4. Exactly. Good. We pick 4. So let's see. Next one, we pick z is 4. X squared plus y squared equals 4. What is that? A circle's radius, what? Radius is 2, exactly. So we got this. And this corresponds to z is 4. And the orange one corresponds to z is 1. Yes. Okay. Let's draw one more. What is the next z value you will pick? Exactly. Very good. So when z is 9, x squared plus y squared is 9. Its radius is what? 3. Exactly. So this corresponds to z is 9. So this is a level curve. Is that okay, everybody? All right. Now let's look at part B. Okay.
So basically, you pick a number for
yes,
z.
you pick a number for z, and you think about what value you could pick. Okay, what is the smallest? What is the biggest? Or if you don't have a smallest or biggest, you just pick some easy number.
Can't it just go infinitely?
Yeah, here in this case, z could as big as you want. You just pick bigger circle, bigger circle, bigger circle. In this case, yeah. Okay, part B. So z is y minus x squared, and then minus 2. Do you see on the xy plane, z is just like a constant. The variable is x and y. Z is like a constant. So here, if you get something like this, do you see that the power of y is 1? Mm-hmm. So it is a function. So we solve for y. We get y. We move these to the other side. We get x squared plus 2 plus z. Is that okay, everybody? X squared plus 2 plus z. Now, z could be anything. And z is a number. And y equals x squared. What is it? Y equals x squared is a parabola. Yeah. And you add different z. Can z be positive? Yes. Can z be 0? Can z be negative?
Yeah.
Yes. So in this case, z could be any number. And what happened to the different z? You just shift the parabola up or down, right? So let's pick different values for z. I usually pick z is 0 because that is the easiest one. And then I can plug in different z. By the way, the level curve, you just pick 3 or 4 values of z, and it's enough. Then we can see what the level curve look like. Okay, so when pick z equal to 0, we get y is x squared plus 2. This is a parabola with the y-intercept 2, right? And parabola looks like that. And this corresponds to z is 0. Yes, everybody? And next, what do you want to pick your z to be? It can be positive or negative, doesn't matter. 1? Okay, good. 1, and then the y is what? X squared plus 2? Yeah, plus 2, and then plus your z is 1, so it's x squared plus 3. Oh, it means the y-intercept is 3. Yeah? And you also draw a parabola. So this is z equals 1. Okay. Let's do one more value. What z do you want to pick? Negative 2. Yeah. Then your y is x squared. X squared. It passed through the origin, right? Z is negative 2. Yes. So the level curve is a bunch of parabolas. Okay, everybody? Yeah. Okay, so this is part B. And, everybody finished part B? Okay, good. Part C. Okay, the labeling. I should, something wrong with the labeling. Okay, so what happens if we get something like this? Okay, so z equals 5x squared plus 2y squared. Okay, if you see x squared plus y squared, we know it's a circle. But what if the coefficient of x squared and y squared are not the same? This corresponds to ellipse. Okay. So standard form of ellipse is x squared over a squared plus y squared over b squared equals 1. And then it depends on a and b, which one is bigger. So if a is bigger than b, then your ellipse looks like this. This is a, this is b, and a is called a major axis, b is called a minor axis. Have you learned something like this? Long time ago, right? Ellipse. Have you learned something like this? No? Okay. All right, then you can remember it now. Okay, so the standard form for ellipse is x squared over a squared plus y squared over b squared equals to 1. You know, for circle is just a special case of ellipse when the a and b are the same. Imagine if a and b are the same and they're both r. You get what? x squared over r squared plus y squared over r squared is 1. Both sides multiplied by r squared, you just get x squared plus y squared equals r squared, right? Okay, now let's see. We pick c to z to be different number, and the smallest. Do you see the smallest is also when z equal to 0? Yeah, because square, it must be greater or equal to 0. The smallest is when it's 0. So we draw it like that. So 0, 0 is origin. The origin corresponds to z is 0. Okay. And then how about when z is not 0? Okay, when z is not 0, let's change to the standard form. So we change to the standard form. You see the standard form, the other side, the number is 1. So let's divide it both sides by z. We get 5x squared over z plus 2y squared over z equals 1. Yes, I'm trying to change into the standard form. So I make the right hand side as 1. I divide it by z. And I want to move the 5 downstairs so that I have x squared over something squared. So I get x squared over z over 5 plus y squared over z over 2 equals 1. Is that okay, everybody? And then I want to, my last step, I want to express this is something square. Okay, I can put a square root there. Plus y squared. And then I want to express as something square. So then I have z over 2. So we express this like the standard form. My a is like, bless you, square root of z over 5. And my b is like square root of z over 2. Okay? So we pick different z values and we have different numbers. In this case, it's hard to get nice number integer. So we don't really need integer. But you can see a and b, which number is bigger?
B.
B, because you divided by 2. This one you divided by 5. This is smaller. So B is bigger. So it means your ellipse, instead of like this, your ellipse like it's gonna be like this. It's longer on the y-axis. So so you can see here. Let's say if we pick z equals 1, and then the a will be square root of 1 over 5. That's the a. And your b is square root of 1/2. Right? Because you pick different z. If you pick z is 1, and then your a is this length, is square root of 1 over 5. And then your b is this length, is square root of 1/2. Yes. And now you just plug in different numbers for the z. Okay, now I pick z equals 2. Then this will be what? Square root of 2 over 5. Yeah? And this will be the square root of 2 over 2, which is 1. Exactly. And can you see the pattern? Your z bigger, and you just have a bigger ellipse. So you can kind of stop here. Just usually, I hope you draw 3 values of z, then you can see the pattern. Is it increasing or decreasing? See the pattern. Okay. Any question so far? All good?
So the last one, z equals 3y plus 7x. A linear function is a line, right, everybody? And usually how you draw a line is you kind of solve for y. So solve for y, I got minus 7x. I get 3y is minus 7x plus z. Yeah. And then y is minus 7x over 3 plus z over 3. And great, this is the slope-intercept form. Your slope is negative 7 over 3. And then z over 3 is the y-intercept. We know they're lines, right? Okay. We're going to draw them on the xy plane. Okay. So look at the y-intercept is z over 3. And, okay, what do you pick the z to be? Easy number. I pick z is 0. Do you agree? Then z over 3 is 0. Okay, then we get y is negative 7 over 3x. So we have 1 point is the origin. And, you know, what is slope is rise over run. Yes, everybody? So you can think of this as negative 7 over 3. So it runs 3 units and go down 1, 2, 3, 4, 5, 6, 7. 7 units. Yeah, rise over run. And so this is what the line look like. Yes. Do you remember how to draw the line? You find the y-intercept. You look at the slope, and as run, go to the right. How many units? Rise. Rise is negative, so you go down 7 units. That is when z is 0. In this problem, we can actually pick integer points. What is the next z you pick? So you get integer points. 3. Awesome. So we pick z equals 3, and your y is negative 7 over 3x plus. Exactly. So we get 1 here, and then like that. A lot of line parallel to it. This corresponds to z is 3. Okay. And the green one was z equals 0. Okay. So different lines have different heights. Let's do one more. What z do you pick? 6. So z is 6. And then your y is negative 7 over 3x plus 2. See, the 2 is here. And we draw the line, and we know z equals 6 on the line. Is that okay, everybody? Mm-hmm. So you imagine this is a level curve. So your plane, okay, so this is the xy plane, right? And now in the space, you see your z is increasing like that. So the plane is something like that. Can you imagine? Yeah. And here we have a not quite ellipsoid because this is a ellipse, but the surface is gonna be something like that. Can you imagine? It's growing bigger and bigger like that. Yes. So this is the level curves. Any questions about level curves? No? Okay. All right. So example 4. Here is a contour diagram for a function g. Use the diagram to answer the following questions. What is g35? So you see the x. Let's choose 0, 2, 4, 3 is in the middle, right? So 3 is in the middle. And so you go over 3, 5. Do you see 5? is at this point. What is the height of this point? A little bit bigger than 0.5. It would be 0.6. Yeah, I think 6. So 0.5, 0.6, 0.7, 0.8. Yeah, see? It's 0.8. And that's 0.9. Yes. So good. This is 0.6. Is that okay, everybody? Mm-hmm. And what is the highest point on the diagram? What is the lowest point shown? What is the biggest height? Biggest is 0.9, right? We don't see any dot here, so we don't reach 1. The highest is 0.9, right? So the highest is 0.9. The lowest, yeah, 0.1. The smallest number is 0.1. Okay, if you start at 3, 5 and head in the positive x direction, do you go up here or down here first? So you go to the positive x direction. Do you go up here or down here? Your height is increasing or decreasing? Ah, yes, everybody. You go up here and maybe you reach the 0.7 and then you go down here. Right, everybody? So we can say if we go up here to like a 0.7, then we go down here. Okay. So far, so good, everybody? This is what we can know from the level curves. Okay. Next concept, distance between points. Do you remember the formula for the distance of the 2 points? Is the square root of the change of x squared plus the change of y squared, right? The distance between 2 points. That is because of the Pythagorean theorem. Mm-hmm. Yeah, this guy's square plus this guy's square is this guy's square. But what if we have 3 points in space? 3 points in space, then you have this guy. And this guy. So this guy, let's say this is the change of s. So change of s is the square root of change of x squared plus change of y squared. But now your distance, the PQ, if you look at this triangle, is a right angle triangle. And you have change of s squared plus change of z squared is this distance squared. Therefore, change of s squared is this square root square. It just becomes change of x squared plus change of y squared plus change of z squared. Okay? So the distance between those 2 points, then you can put distance is the square root of, look at your x. Your x is what? 7 minus 1 square. Yeah, 7 minus 1 square. How about your change of y? What minus what?
5 minus 2.
Yeah. Good. How about change of z? Exactly. Good. Okay, what is 7 minus 1? 6. So 6 squared. 5 minus 2? 3 squared. And negative 3 minus 3? Negative 6. So what is 6 squared? 36. 3 squared? 9. Negative 6 squared? Yes. Okay. What is that? Okay, 36 plus 36 is Exactly. Very good. What's square root of 81? Exactly. Okay, everybody? So the distance between 2 points. Just use a formula. Okay, so this is session 9.1. Any questions about 9.1? Good. Let's go to 9.2. Okay. All right. Let's see. By the way, your next exams cover chapter 8 and 9.1, 9.2. Okay, because the remaining of chapter 9 are hard. Okay, so yeah, we just talked about the contour maps and level curves. Okay, now look at this picture. Suppose you start at the point 1, 1. Okay, how do we look at this picture? Do you see here is 0? Do you see here is 0? Mm-hmm. So if you draw the XY plane, this is X and this is the Y. 1, 1. Where's 1, 1? Your X is 1 and your Y is 1. Do you see this point here? This point is 1, 1. See, X is 1 and the Y is 1. So we're.
Why are the ones negative on?
Hmm?
Oh wait, no, never mind. That's a dash. That's
Oh,
dash,
yes.
not a negative one. Okay.
Oh, yeah. Okay. All right, so that's the point 1, 1. Suppose you start at that point and you begin to move. What happened to the values of the f? Yeah, it depends on which way. Okay. 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 Let's see. If we start moving in the positive x direction, what happened? The positive x direction. By the way, here, what is my height? My height is 0. In the level curves, we're standing at this point. My height is 0. Right? If we move to the positive x direction, what happens to my height? Goes up. Go up to here is 0.5 and here is 1, here is 1.5. Right? So we can see the f increases from f0 to the bigger one. Okay? And if we start moving in the positive y direction, what happens? If we go to the y direction. Here, what happens? It's negative 0.5. Here, negative 1. Here, negative 1.5. So f decreases. And it was from f is 0 to the negative numbers. Is that okay, everybody? Okay, so in order to understand exactly how the multivariable function changes as the input varies, we extend the notion of derivatives from the applied cal one. Okay, applied cal one, we only have a single variable. Now we have 2 independent variables and 1 dependent variable. So we call this derivatives partial derivatives. So partial derivatives, the idea is we differentiate with respect to one variable while holding all the other variable constants. Okay, so if we go to the x direction, then the y remain constant, right? This direction, the y remain constant, and your x is changing. If we go to the positive y direction, the z remain constant, and the y is changing. So that's why do you still remember our basic definitions of derivative? Is the limits of the slope. Okay? Slope is change of y over change of x. So in this case, it's the limits of the slope, but now it's change of the z. So this is the new point, and this is the old point over change in x. Can you imagine, everybody? This one is we have the y remain constant. Okay, so you see the b is still b, so the b is not changing. So in this case, y is constant, and we let the x varies. Okay, and so this is a partial derivative with respect to x. X is the variable, y is like the constant. And here is the partial derivative with respect to y, and we treat the x is constant and the y varies. And the Leibniz notation for the partial derivatives is like this symbol. It looks like a 6, but you kind of flip it over. Okay? And so this is the partial f, partial x. And we also use this small notation. Partial f, partial y equals f sub y. Okay, and computing partial derivatives is similar to computing ordinary derivatives, except to find fx, you treat y as a constant, you differentiate with respect to x. And to find fy, you treat x as a constant, and y is a variable. You take the derivative with respect to y. Is that okay, everybody? So everything we did before works. And let me remind you, derivative formula. What are the derivative formula we learned so far? So x to the n prime is n times x to the n minus 1, right? And derivative e to the kx is e to the kx times k, right? And we also have Pareto's rule. Remember Pareto rule? You and your buddy go to the restroom together. So u prime v plus uv prime. How about quotient? U prime v minus over. Yes, very good. All right, everybody? And we also have chain rule. Well, chain rule is our new formula. Or maybe we can do this dy dx is dy du times du dx. That's the chain rule. Okay, so that's what we learned before. Now, let's look at the example 1. This is the function f. Define fx and fy. Fx, we think about y is a constant. X is the variable. What's the derivative of x cubed?
3x squared.
Yes, 3x squared, right? 3x squared plus, so, and then x squared, y cubed. So y cubed is like a number. Okay, y cubed is like a number. Constant multiple stays here. What's the derivative of x squared? 2x. Yes, everybody? And the next term is a number. What's the derivative of a number? Number. Derivative of a number. Just 0. Okay? So y is the constant. X is the variable. So this is the partial derivative with respect to x. Okay, now you tell me what is partial derivative with respect to y. Now,
X is a constant. What's the derivative of x cubed? 0, because it's a constant. And then here, do you see x squared is a number? It stays here. What's the derivative of y cubed? Exactly. And then the derivative of negative 2y squared is? Exactly. Very good. So derivative, very similar to what we learned before, but you just treat one of the variable is like a constant. You differentiate it, only negative. Okay, so we will continue. Next time we plug in the 2 and 1 and we evaluate the number. Okay, so yeah, make sure you print out session 9.2 next class. And also print out 9.3 because after 9.2 we do 9.3. Have a good day.